Today's presentation is about solving and graphing compound inequalities. Compound inequalities are two inequalities that are put together as one, just like compound words. Like you could have the word play and you could have the word ground. But once you put them together, two separate words become one playground compound word. So we will be taking two inequalities and putting them together to form one compound inequality. This first type of compound inequality we're going to look at has the variable term in between two inequality symbols. So this reads the negative 3 is less than x is less than or equal to 2. And what it means is negative 3 has to be less than x. That's one criterion. And x is less than or equal to 2. That's the second characteristic that must be true. So it's like if I told you you needed to wear both black and brown tomorrow. For you to fit my requirements, you'd have to wear both black and brown. So to solve and graph the compound and inequalities, where the x is between two inequality symbols, you have to solve each part. That's the first thing. In this case, x is already on a side by itself, so all parts are already solved. So we can go to the next part, the graphing each inequality, each part. So negative 3 is less than x. Sometimes people get confused if the x is not on the left-hand side. So we can reverse the entire inequality. X, negative 3. The opening goes to the x, so I'm going to write it like this. So now we can say x is greater than negative 3. Some people have absolutely no problem leaving it that way. What we know is that we have to put an open circle at negative 3 because x is not equal to it, it's just greater than, and x has to be greater than, or negative 3 has to be less than all of the x's, so it goes this way. To graph this portion, x has to be less than or equal to 2, so we're going to put a closed circle at 2, and it's all of the solutions this way. The total solution is where they overlap. So it is this part right here. That is the solution. X could be anything in between negative 3 and 2, not including negative 3, but including 2. Alright, here's a slightly more complicated and inequality. So we see our variable term is between two inequality symbols, so we know that it has to fit both of these criteria. So what this means is negative 9 is less than 6x plus 3, and 6x plus 3 must be less than or equal to 39. So the first thing we're going to do is solve each part. So here's my variable x, so I have to subtract 3, and I have to do the same thing over here. And I usually do both equations or both inequalities at once. So this gives me negative 12 is less than 6x, and 6x is less than or equal to 36. I have to divide everything by 6. And again, I usually do both at the same time so I don't forget. So we have negative 2 is less than x, and x is less than or equal to 6. And we can put them back together. Negative 2 is less than x is less than or equal to 6. Some people see the graphing easier if it is written as one inequality because they can see that the x has to be between negative 2 and 6. So it is not equal to negative 2, so we're going to put an open circle. It is, or it can be, equal to 6, so we're going to put a closed circle, and it's everything in between there. I want to admit to you that sometimes I don't actually split this up into two inequalities. We certainly could. 17 is less than 5 minus 3x, and 5 minus 3x is less than 29, but sometimes I solve it kind of like it is a three-part inequality. So here is my variable term, so I have to subtract 5 from every single part. So 12 is less than negative 3x is less than 24. And then I am going to divide everything by negative 3. So negative 4 here, x here, and negative 8 here. Remember though, we just divided by a negative number, so we have to flip all of our signs for it to make sense. I do not like leaving it like this though, because it is not in numerical order, so I'm going to rewrite it. Negative 8 is less than x is less than negative 4. Some of you might be thinking, okay, if I don't rewrite it, will it be counted wrong? I will definitely circle it. You need to make sure that it goes in numerical order. So when you are graphing it, if you need to, you can see that x, so the solution has to be between negative 8 and negative 4. And we're going to leave those open circles because it's not an equal to. So it's not a less than or equal to or greater than or equal to. The last type of compound inequality that I want to talk about is where the x's are not, the x term or the variable term is not in between, but it's almost like two separate phrases connected with an or. It is like I said to you, you can wear blue or black tomorrow. You don't have to wear both. So to graph this, in this case x has to be less than 2, so we find 2 and we circle it, and it's anything less than that. Or x could be anything greater than 6. So we circle the 6, and again they're not filled in because it's not an or equal to, and it has to be anything greater than that. If there are other parts of this variable expression like x plus 2 or 4x minus 3, you would have to solve it before you graphed it, but those are or inequalities. The arrows do not overlap. They are two separate inequalities graphed on the same number line, and that's compound inequalities.